Hi everyone, welcome back. In this video, we will discuss some great IoT projects. Without further ado, let's start with ESP Dive is a fully functional, Wi-Fi controlled submarine that lets you explore the underwater world in first-person view. The submarine's body is 3D printed in multiple sections and assembled using threaded rods and nuts. The front dome is made from a transparent plastic bottle cap, allowing the onboard FPV camera to record a clear underwater view. 3 core mechanisms control the submarine: a pair of DC motors for forward and reverse movement, a ballast system for diving, and a servo motor that connects to a rudder at the tail to change direction. The power to all the components is supplied by a rechargeable lithium battery placed inside the main hull. You can view the live camera feed, adjust rudders and propellers, and fine-tune buoyancy in real time. Giovanni made a smart energy meter to monitor a home's electricity usage in real time. It gives a clear picture of how much power is being consumed at any given moment, as well as over specific periods, like the past day, week, or month. The system uses a current clamp and transformer to measure voltage, current, frequency, power factor, and total energy in watt-hours. These readings are processed by the microcontroller and transmitted via Wi-Fi to the Home Assistant app, where you can view detailed interactive graphs of their consumption trends. A 3D printed case makes the device compact and professional looking. To make the setup more user-friendly, a small onboard display shows real-time measurements directly on the device. Best of all, there's no need for major changes to your electrical system. The clamp fits right over your cables, measuring usage without requiring disconnections. This project lets you see live images of Earth captured directly by the Fengyun FY-4B weather satellite. This satellite is part of China's second-generation geostationary meteorological series, launched in June 2021. Since it stays fixed over one point on the equator, it captures continuous images of the same region, making it possible to create real-time Earth time-lapse animations. The setup uses an ESP32 development board with a touch display to fetch the latest satellite data directly from the internet. FY-4B updates weather images every 15 minutes, with about a 45-minute delay due to transmission and processing. Each downloaded image is stored on a micro SD card using a structured folder format based on date and time. Between downloads, the system plays the saved images in sequence, creating a smooth time-lapse effect. Sebastian made an innovative wind gauge design, which does not include any moving parts. That's right, there are no spinning cups or wobbly arrows. It is just a clever way to measure wind speed and direction more reliably. The core structure features an omnidirectional sail, designed to respond evenly to wind from any direction. The sail is fixed to an aluminum tube while the crossbeam is made from a thin, strong, and slightly flexible material. 4 strain gauges are precisely attached to it. These strain gauges detect tiny changes in resistance when they're stretched or compressed. When wind pushes the sail, the post bends slightly. The stronger the wind, the greater the bend. By tracking this bending in 2 perpendicular directions, north-south and east-west, the system can accurately calculate both wind speed and direction. Before we move forward, a word from our sponsor. Altium Develop is a cloud-based platform that unites every part of electronics product creation in one shared space. It combines Altium Designer and Altium 365, allowing electrical, mechanical, and software teams to work together with shared data and real-time visibility. Instead of using separate tools or holding long meetings, teams can collaborate instantly and see every change as it happens. This helps them stay aligned, make faster decisions, and reduce errors. Designed for small and mid-sized organizations, Altium Develop removes the friction and extra cost of traditional workflows. It also lets teams invite unlimited free collaborators, so everyone involved, from engineers to suppliers, can contribute easily. Give it a try. It might just be the upgrade your workflow needs. This interesting project will guide you on making a DIY-free dark sky meter, an instrument to measure light pollution using simple and affordable components. At its core is an ESP32 C3 microcontroller, which handles data collection and wireless communication. The ESP32 reads inputs from a light sensor to measure sky brightness, along with a temperature and humidity sensor to log atmospheric conditions that can affect light pollution readings. The captured data is transmitted via MQTT to a remote server for storage and analysis. What's impressive is that this affordable setup, costing under $65, produced results that closely match those from ESA's Gaia satellite, proving that even hobby-level gear can yield scientifically reliable data. Everything from the firmware to the 3D printed case design is open source, allowing anyone to replicate or modify the system for their own location or research. And because of ESP32's low power consumption and Wi-Fi connectivity, this device is well suited for continuous outdoor operation. Circuit breakers are usually operated manually, but CyberLab decided to take a smarter approach. He replaced traditional breakers with Wi-Fi controlled ones, allowing remote operation through a smartphone app or even voice commands.
Алиса, включи отопление на среднюю мощность.
Окей, поехали.
In winter, when everything around his home stays buried in snow, checking the drainage well becomes nearly impossible. If the pump inside fails, surface water can easily seep under the foundation, which is a serious risk. With the new system, he can now monitor the drainage pump's performance and track energy consumption directly from a connected dashboard, ensuring it works as intended. He later expanded the setup to include his hot water boiler, using the breaker's built-in safety feature that shuts off power automatically after a set time. This not only prevents overheating, but also saves energy when appliances are left running by mistake. Imagine having a smartwatch that's a command center for your entire IoT setup. That's exactly what this creator has built with this Gateway Smartwatch project. It features high-precision timekeeping, tilt-to-wake functionality, and even atmospheric condition monitoring. A built-in LiDAR-style distance sensor allows for accurate proximity detection, while a laser pointer adds precision for aim assist tasks. The MAC addresses of the watch can be switched on the fly. This means it can instantly connect to virtually any number of ESP-based devices you've got running, like lights, locks, or sensors. The creator has also added hotkeys, so with a tap, he can unlock a door lock or switch off the lights. And the best part is that a quick 43-minute recharge via USB-C or magnetic charger gets it ready to go again. Our next project is an AI-powered fault diagnostic system. The device is modeled after a closed-loop PC water cooling setup. It uses a water pump, plastic tubing, an aluminum radiator, and custom 3D printed components. To detect cooling malfunctions, the setup combines data from multiple sensors. A thermal camera continuously scans the system to capture temperature variations across pipes and components. At the same time, a neural network analyzes the sound patterns produced by cooling fans, since unusual noises often indicate issues like friction, imbalance, or motor faults. The system also uses a visual anomaly detection model to compare live thermal images with normal operating patterns, spotting any unusual heat spots or uneven cooling. Together, these inputs help the AI pinpoint exactly where and why a malfunction is happening. The web dashboard serves as the control interface, where data is transmitted from both the sound and thermal sensors, processed through machine learning models, and displayed for the user. The dashboard also sends alerts via SMS and logs system updates. In this project, Lewis set out to build a magic mirror. At first glance, it looks like an ordinary mirror. But behind the reflective surface lies a digital display that shows everyday information right into view. He used a 21-inch monitor, carefully fitting it behind a two-way mirror. This allows light from the screen to pass through, while still reflecting the viewer's image. To hold everything together, he designed a custom wooden frame, precisely cut to house the electronics and give it a clean, modern finish. At the heart of this setup is a Raspberry Pi, which powers the smart interface. It gathers data, updating time, weather, calendar events, and reminders in real time. A motion sensor detects when someone enters the room, waking the display only when needed. An ambient light sensor adjusts brightness automatically, ensuring clear visibility whether it's day or night. Next on the list, we have a smart fridge calendar built by Eric. It connects directly to Google Calendar using the Google Calendar API and updates the e-paper display automatically at midnight. The screen shows up to 6 upcoming events, including the title, date, and short description, fetched directly from the cloud. The display used here is a 9.7-inch e-paper panel, and the frame for this display is made from a modified picture frame. Despite the slightly mismatched size, it fits neatly and gives the project a finished look. The events are drawn one by one instead of refreshing the entire screen at once, a slower but visually pleasing update method that gives it a smooth, gradual transition effect. Since the device runs on battery, low power consumption is critical, so after each update, it enters deep sleep mode to conserve energy until the next refresh cycle. Our next project is a fully automated smart chicken coop door. It manages daily tasks like feeding, door control, and predator alerts, all through your smartphone. The first major feature is the automatic split door mechanism. It's driven by a NEMA 17-stepper motor, GT 2-timing belt, and metal rods, all mounted on a sturdy MDF structure. Next is the AI-based security system using the Husky lens. It's trained to detect common predators like raccoons or foxes. Once it spots a threat, it sends the information to the Arduino via the I2C interface, which instantly triggers email alerts. Feeding is fully automated too. The coop includes a funnel-shaped feeder with an auger screw driven by a continuous rotation servo motor, dispensing food on demand. 2 identical feeders are used for reliability. This project demonstrates how to build a compact, low-cost ECG monitor using an ESP32 microcontroller and an AD8232 ECG sensor. The sensor captures the heart's electrical signals, while the ESP32 processes and streams this data wirelessly to a smartphone or computer for real-time monitoring. One best feature of this monitor is that the entire setup is simple and portable. Despite its minimal component count, it reliably records clean ECG waveforms and even flags irregularities like arrhythmias, all without the need for bulky medical equipment. The entire design is open source and affordable, costing around $65, allowing hobbyists, students, or researchers to replicate or adapt it for their own needs. This project is a smart water quality monitoring system designed to catch early signs of underwater pollution by spotting air bubbles and analyzing chemical test results. To simulate polluted water conditions, Actar set up a planted freshwater aquarium and connected the system to it. The air bubble detection unit uses a nano ESP32 with an ultrasonic sensor, an accelerometer, and a small display. It collects scan data, runs a trained model to detect harmful air bubbles in real time, and sends the results to a web server. For chemical testing, he used a single board computer with a webcam and touchscreen that checks water test strips and sorts them into pollution levels. Both boards are linked to a custom web app and send updates through a Telegram bot. To bring everything together, a custom squid-themed PCB and a 3D printed mount were added to the aquarium. This smart pill dispenser ensures you never miss a dose again. Through its companion web app, you can name each pill, set the dosage, and schedule exact reminder times. Once the pills are loaded into their slots, the system automatically handles the rest. At its core lies the Photon 2 microcontroller, managing motor control, data syncing, and cloud-based notifications. A 2-inch WaveShare IPS display shows real-time updates, while a metallic LED push button allows easy manual dispensing. When the button is pressed, it checks whether the current time falls within the valid window for a dose. If it does, and the pills haven't been dispensed yet, the controller activates the stepper motor to release the right pills into the tray. If the button is pressed outside the valid time window, the dispenser remains inactive, preventing any accidental or premature dispensing. Our next project is a smart hiking band designed to detect falls and give alerts instantly. It uses a gyro sensor to monitor orientation and motion, recognizing abnormal impacts as a fall. When triggered, it sends the hiker's coordinates through Blink, notifying the guardian via both phone and email. Alongside that, A heart rate sensor keeps track of pulse and SpO2 levels, displayed in real time on a small OLED screen. There are 2 control buttons, one for switching between modes and another dedicated SOS button. Pressing SOS sends an alert with GPS coordinates through Blink. Everything runs on an ESP32, powered by an 800 mAh lithium-ion battery with Type-C charging. The components are neatly mounted on a perf board and enclosed in a 3D printed case. If you've made it till here, then drop a like and subscribe to our channel to keep supporting us. We will be back with some great ideas soon. Till then, goodbye.